So, hello there. Are we live? We hopefully are. Yeah, I have to break out the the Twitch cause I'm also again streaming on Twitch, so yeah. Um so let's pop out the stream chat as well. Let's pop out the YouTube chat, and I think we're good to go. I hope, at least. Um Let me open ChatGPT for a second, because unfortunately I do sometimes need it. And well, let's we could wait a bit until the yeah, I did something off cam. We gotta wait a bit until the YouTube initializes, hopefully, because I don't see any streaming analytics now. Yeah. Not available, not available. Yeah, sure. Whatever. I hope you can hear me well. Hey, hello, hello, hello. Yeah, that should work. That should work fine. Um, wait, let me make it this loud. Yeah. So, yeah, we're good to go. Oh, so yeah. Now see the analytics. We're good to go. Where was I? I was at the just wait a second. Yeah. So there was this I had a partial success of well, mounting the VFS, the Fuse FS. We're obviously gonna move the VFS to another module, to another executable daemon, actually, because in certain under certain conditions we just don't need the VFS. Yeah, we just don't need the VFS, so we're not gonna be mounting it, but it can be mounted. Though again, with later we're gonna be moving it to two separate demons to well work with it. But uh for now we are good to go. Um, so how far are we? Um, wait a second. There's just Yep. Sorry. I don't like any words and any lyrics in any music. So yeah, what we did is what we successfully, or better say what I did, huh? Right? Is we did the get address. We implemented it fully. Oh no, sorry. We did not. File attribute. Um, we did the partially the redirectory. Um, we partially did the redirectory, yeah. And yeah. So here's the question: what are we gonna implement next? Offset root. We don't have this one as well. Um, First of all, is this online? No. Um, let's reply to that. Why don't I see actually any data here? So let's read about it. Purpose function is used to resolve a specific directory name within a parent directory. It maps parent to specific nodes. The function is called, what it does, it takes the parent directory's inode and the name of the file or directory. It queries your key value storage KVS to fit the inode associated with the parent and name pair. Huh? If node is found, it retrieves the attributes and send them back to the kernel using reply.entry. Oh, so we already got this. Inode, oops. Implemented. Oops, sorry, we got this. Get KVS. We got this implemented, so we don't care. Read directory is used to the components provides the metadata of files or subdirectories within the directory. Use case when the file system receives a request, list all the contents. Functions called to enumerate entries in the directory. It takes inode of the directory and the offset to support the pagination. Do we actually need these? I don't think so. It checks the inode corresponds to valid directory. It adds the directory and current pages directory to reply. Fair enough. Yeah, for some reason I didn't see the params properly. So number of the directory being listed in your code is defined as 1, the slash, fair enough. This is the offset. Can we pass the inode here safely? Since we're covering the inode, we just pass it, can we? If is the offset. The offset is used to keep track of the position in the directory listing, allowing the kernel to resume listing at the point if needed for the pagination results. Yeah, so it's just an index. Okay, fair enough. File type directory specifies what type the directory being listed. Okay, is the name for the directory entry. What I have to do I have to define? This is the offset. sense. Um, yeah, I'm really trying to. That listing should typically include the names of the entry, corresponding unknown. A Fuse implementation is currently hard coded on the return. Um, not can be taken from the So I bet we're it's just the absolutely should read the inode offset. Lists root directory contents of another directory. Oh, so the first parameter is basically the child I is the first parameter. That's just what I want to know. Yes, reply that first parameter is a child I know for each directory. Okay. So it started making sense. Reply. What is a reply? Mutable reply. Reply directory. So what are we gonna do now? Let's go to directory first of all. Directory function. Oops. Directory reply. Is the reply? Nope, not the reply directory. We got a self and the reply. I will return the reply directory. Entry soft on entries clone. Yeah, we're gonna use start reply directory. Yeah. Now reply directory. Oh, so it should accept the reply. Will offset at the dot directory, at the dot directory. Yep, that's more like it. Hope it's not all too loud. Yeah, hopefully it's not. Um, um, how long? Yeah, 15:33. I'm streaming. So for each entry in self.entries, it's a directory entry. Um, hmm. Now we gotta determine what this directory entry is. We just see the inode, but we can't we just know that there's a certain inode. Oh, yeah, sure. We can sure we can just sure we're just storing the type, are we? Um, mm, um, node get by ID. Do you have it here? Use. Yeah, hopefully this will work. So we get the inode. Wait, where are we? Um, where are we? What the shit? Directory, get by ID. Huh? Yeah, oops, sorry, yeah, here we are. File type, inode kind, super inode. Yeah, well, we'll leave it like this. File type, enter inode ID, offset +1, entry.name. Do we actually need a pointer or something? Don't we have to copy it or something? I mean, get directory reply. Get by ID. Yeah. Oh, so we can. Inode, we can get it, but by ID, right? And wait, let's fix theirs for now. What we have currently here. I mean, I gotta disable the unused imports warning, but unmutable. Um, why exactly? Because request reply entry. Mutable reply entry. Yeah, reply directory. Sorry, reply directory. It returns the reply directory, and we return it manually. So that should solve the problem. Should it? Will it? Oh yeah, partially. Oh, it actually did solve the problem. Mutable self dot get kvs. Storage method not found. Huh. KVS, we put pass it here, and okay, this one works. Directory is empty, and it's getting requested, and so on and so forth. So yeah, what's next? Um. So next we are gonna be inode. We're gonna be get attribute of the file attribute. Mm. And get nope. I'll get what is this called? Get target. Oh yeah, sure. So get target is a Southern KVS. The result is actually a result is actually a well, inode kind and an ID. Um yeah, that makes the much easier. Yep. Good enough. Well, at least it runs. Right. So well, ID, directory.id, yeah, and the symlink we just don't care for now. We just leave it unimplemented and yeah. Oof, sorry. Get target. Let target. No, not the inode, but inode kind um equals um unwrap. Hope this one's gonna work. Um, what was it again with this unwrapping around stuff? Um, hold up a second. Note used. Oh yeah. So is this one's an error? Yeah. Yeah. Hopefully this is gonna work. Unwrap dot get target. Um. Oops. Yeah. Um. What is the problem? Oh, so we just forgot an import, right? Mm-hmm. Directory one. Okay, so good. We're unmounting it. Yeah, yeah. So we were mounting it successfully. That works. That helps. So what's next? Attributed. Um, that's the lookup. Sorry. Read directory. Directory get by ID. Can we just reassign it like directories equals directory.unwrap? Oh no, so we're gonna be violating the explicit type of the yeah, well, of the Frost. Good. So directory reply offset, updated reply.ok. Um, yeah, something's wrong. Sorry, I gotta switch to music. Something's wrong. Um, Did I uh, the issue occurring to an infinite loop or handling of the offset parameter in the redirection implementation? The offset parameter used to track the position of the current directory listing, and if it's not managed directly, it can cause the read their function to loop indefinitely. Um, nope. Wait a second. So it's there's an offset problem. The offset is incremented properly. We need to ensure. And where to fix? I guess it's somewhere in the directory here. I guess. Likely to do if you import problem in your implementation is being passed, but it seems that the offset is not being updated correctly or being reused improperly. It causes the same entries to be processed repeatedly, reading the infinite loop. Data. Directory. The offset is passed to get directory reply, but it doesn't seem to be updated or incremented properly. Processing each entry, meaning the same entries are being processed repeatedly and the redirectory function never exits. Oh, so it's just that fragile. Okay. You need to ensure that the offset is updated correctly. Update the offset after processing each entry. Yeah, do we do this? Like offset? Um, yeah, offset. Yeah, we have the offset here. Yeah, that's strange. I mean, obviously I'm trying to do it myself, but I'm just looking at what the problem might be. Yeah, so there's this offset. Skip the process entries. Dot enumerate. Dot -2 or something, right? Modify function to properly handle. Should skip entries that of already been processed. So if we add these directories only and only if and only if offset is equals to 0, then we first of all add well, a double dot, right? A dot and a double dot. Reply with the double dot and the offset, the increment with the right. Okay. It's being looked at. Test the fast. Oh, so we are good to go actually. We are good. So we have an empty directory here. I mean, I can show it to you. It looks just like this. So here's the project. Here's my test image. Yeah, sorry. Yeah, that's the image I really wanted to test it on. And we have this test fast. And we go back again, as you can see, and forth, and yeah, directory, inode number, lookup fetch. It tries automatically to fetch trash. Trash 1000. Yeah, and it fetches it as a directory with no entries. So that's where we're at. So far so good. Yeah, first of all, let's do a commit. fixed all offset errors. Added basic I know and directory mappings. Again, we're currently using Redis as a key value storage, but again, that's gonna change. We're gonna change that. So now we want to create files. Yeah, we committed it. Now we gotta work with creating files. Where is that? Redirectory. What do we have it implemented? Yeah, we have to we just implemented it. So yeah, we just mark it as implemented. Implemented as well as this guy here, making a lookup. Implemented as well. Good. Get attributes. We gotta have the attributes, the reply attributes. That's an easy one. I believe we already have this get attribute. Yeah. I believe we do actually have this one already. So I mean, let's look at it a bit. We're getting the attributes. So let inode use like just the same drill as everywhere else. Inode fetch from KVS. Again, not found. We're unwrapping it. And we're getting the attributes. Yeah, I think that's just it. Sorry, we don't have to forget to unmount the directory constantly because it's auto mounted, but it's not unmounted. Go to the testfs and yeah, as you can see, it just works fine. So we're even ready with this one. That was fast, but the other things won't be as fast as whatever. So implemented, good. We've just implemented it, and it's pretty. Again, that's pretty good. That's pretty fast. Yeah, we have open and read, and here's the question: how do we create a file? Wait, let me just run it. Yeah, and yeah, I'm on inside. Good. Lookup parent is equals to text txt. Inode fetch loaded inode lookup cannot touch input output error. Wait, I just don't like this music. Yeah, that's better. Input output error. Function. Do I have to implement to allow creating, deleting files? Because reading and writing obviously makes sense. Create this function is used to create a new file. Unlink this function is created to delete a file and make directory this function. If you want to allow creating directories, you should implement this as well. So that's what we're gonna go with. Make a directory. Wait, file. Seconds. Okay. Just okay. Function example. Though that's gonna be an error first because again we just and yeah, now we will have to work with atomacy and God knows what else. Yeah, create. I don't get by ID unwrap directory create a new inode. Yeah, we are gonna attribute um 100 parent inode. So first of all, yeah, parent target. Um, so first of all, we have to select a new file. Here's the first problem. We have to know what. Yep, this music's better. Here's the problem. We gotta know what inode number to take for the file. Um. So generally. First of all, again, we are not allowed to mutate anything, and that's a very damn important point, right? We are not, again, allowed to mutate just, well, anything. We're not mutating anything. I mean, the only thing we actually edit, right, is um the atomic value in the inode. That's the only thing. That's really just the only thing we can mutate and create and whatever. Um, I know. So first of all, let's get do I um so yeah, how do I guarantee table hard links name to handle that without file system using offline image pooling? What the fuck? No, yeah. Again, I'm just looking at the second display. Um, globally unique, never reused, UID v7. Snowflake style, 64-bit IDs. The content addressed. So well, it well, it's just suggesting to use the so-called Blake 3 algorithms file metadata canonical from content. Yeah, this file ID is the real identity. Never reuse it after deletion or reuse only after epoch, and garbage collector with a huge safety margin. that's gotta be too expensive to implement. I'm afraid. I'm really afraid that it's gonna be way too expensive to implement. Hey guys, for everybody who joined. So first things first. There's somewhere a utilities. Uh, um, a fan function. Generate unique ID. Well, that's something. Um, First of all, also use random. We're gonna go random. Um, yeah. Collision handling. Um, that's gonna be it for now. We don't care about it now. We don't care about it now. That's important. Not like we're gonna fix it one day, but now we do not care about it. That's why again marked it with fix me. Sorry, it's I'm oh it's 2 a.m. where I live, so it's a bit too late. But my university just finished. Today was the last day before the exams, and that's kind of relaxing. So I can stay up late and nothing's gonna happen. Cool. So the inode. God. What else? Generate unique ID. So we also have to also basically we are not gonna be creating a new inode. We are not gonna be creating a new inode unless we are actually. We do have to create a new sorry, my bad. We are not gonna be creating a new inode when well when updating something, right? Again, everything is basically well, it's not called stateless. It's called immutable. I mean, it's immutable. As you can see, the KDS store. That's why, for example, these two functions, these aren't public. Why? Because again, storing something would require us to lock it to well whatever. And what happens with simultaneous writes? I mean, yeah, again, we are relying on Redis for now. Again, we're relying on Redis for now. But that's not going to be the case later on. So we're just saying, well, these functions, they do exist. There is a possibility to store and to load something. And also store, for example, would be basically overriding in this case. Or creating, like instantiating something. Yeah, we're going to be instantiating a lot of things. So we have to create a create file to actually have to write it in Node. No, I do not. What data are we actually provided here with? Parent request name OS string. Oh, so yeah, name OS string, the mode. The parent, the name, and the mode. So everything related to a file we're gonna be doing in a file. Someone wrote, just joined, how will you know where the files are? See, that's the thing. There's the so-called, again, we are gonna be using, inodes. Well, wait a second, for some reason the chat didn't work or it updated just too late. Yeah, so here's the thing. We have basically, and the thing is, what I didn't understand first, and it was, I mean, like I'm programming since I was like 8 or something, and I'm not new to operating systems. I had a lot of courses, advanced courses at the university, but what was pretty much insane for me is how the files. I mean, first of all, we're talking a distributed file system here. How the files are stored, and it was just wait, do I have a GIMP something? Hope I'm not gonna expose anything what I drew. Wait a second. Okay. So I believe I have to draw it because again, with when I found out, I was like, holy shit, how does it even work? So basically, what a file system is, I mean, especially a distributed one like Ceph or whatever, I can come up actually with names, with a lot of names. It's basically something of a hash table. I mean, hash table. It's a key value storage, right? And the key, I mean, there's a key. Shit. There's the key, and the value. Key is most of the time it's just like one, and the value is some data. It's the data. It's a structure, which in this case is a so-called inode. That's the only structure we actually have to store here. So yeah, ID is pretty much arbitrary. So it's just the same ID as here first, then target, also an ID, and a kind of let's say it's a folder or directory basically. So when we see, for example, I mean, yeah, we have to fetch the slash the slash, which is always inode 1. So we guaranteed to go here, and we see, well, there's the folder. And we'll look at this ID, and it's, for example, 2. And we go to another key value storage for a folders, right? And here with 2, we have a directory, as you can see. We have an ID, and we have a bunch of we have a vector with a bunch of entries. So here's the funny thing: I didn't actually know that the file metadata. Each file obviously has a metadata, which at least what I thought. No, I mean, yes, it has metadata, but here's the thing: the file does not have actually its name. The file metadata does not store any name. The file metadata, well, it stores how large it is, all kinds of arbitrary data, but not the file name. The file name is actually stored in the top directory. So actually the directory basically stores the file name and the ID of this file. And basically the ID of this file, but not directly the ID of the file, but the so-called inode ID. What do I mean with it? We have this 2, which basically points to a file. So we see it's a file, folder. Yeah, it's called directory. To make it easier. We have a directory here, right? And this 2 points to this directory's key value storage. And the ID2 has basically file 1 for file 2, 6, some data like this. So then what happens is the system says, oh, so here we are. Here we have some files. There's the file name here, and it is stored at ID 4. And well, it may be a folder as well. We don't know that yet. So we go back here to the entry 4, and we again see the ID, the file ID, and that it is a file. right? And from here, the file ID and the file, we go to another key value storage, key value. And yeah, here's the ID and whatever x. So there's the ID x or whatever, and here we have size, permissions, and whatever whatever we need to store the file. I mean to read the file, to get the attributes, and then well, give the, collect the chunks. You may ask why. Why in the hell is it so complicated? And that was the first question I asked myself. And again, here's the thing. So, for example, we want to update a file, right? So we would have, especially in the distributed file system, we would actually have to place a lock here. Right? I mean, that kind of makes sense, right? So not like users can like overwrite and write in the same time. We have to synchronize it somehow. We don't care how. I mean, it could be a lock. It could be, well, mutex. It's most of the time it could be mutex or some kind of lock. That's other scope now. And then we write, and then we turn down the lock. Yeah. Well, do we actually, well, like, does it actually make sense? Can we make it easier for a distributed file system? Because in this case, a distributed file system would slowly become an ACID database, and we don't want to write a freaking database, right? We're doing a distributed file system, which is something else, isn't it? So, and here the smart part starts. Also, an important consideration is how do you, for example, pass the whole data. Let's say we're not representing it like this, but we are representing it as I think FAT32 has it represented as pointers. So here's a certain directory. Sorry. So here's a certain directory. It has a pointer to another directory. Basically, it's a tree, right? So, and how would you represent a tree? Well, it's pointers, right? And it has a file. And obviously, pointers are nothing but local word-long integers who are, well, basically representing not not a value, but where to basically an address of a cell where to find something, whatever, right? Question is, how do you send these pointers over the network? Because when I just started programming, I had a lot of troubles with the pointers, because here's the thing. I tried to send. I programmed in Qt C++, and I tried to send the string over a network, and I was wondering. I mean, as a struct, as a normal struct, right? And I was wondering, like, why the hell is it crashing? And just at the end, I thought, well, holy shit! So yeah, they are also. I thought it's just the basic C or basic C++, but obviously Qt did it as well. They represented basically a string as a string of pointers, so as a chain of pointers. So obviously the first character worked because we like got it, right? And the second one, and then we got a pointer to the second one, and the pointer was like sent directly over the network, and the network device tried basically to access the memory which was not allocated on the new device. So basically assuming the exactly same memory layout as on the other device, which is impossible for a number of reasons. Address space layout, randomization is one of them, for example. There's a lot of stuff, right? for security reasons, obviously. Main reasons are security reasons. So we can do this. And so to really represent that kind of trees, we would have to implement a real GraphDB with again asset compliant and whatever to just store metadata for files. I mean, that doesn't make any sense. It's a huge overcomplication, and we would have to introduce lock mechanism, and again, God knows what else. So, and in this case, why don't we have to lock anything? Well, that's smart, because if when editing a file just remotely, what I do is I create a new file. I call it x1 and new size, and I create a new entry. And here, instead of and then I created the entry, I propagated it through the network. So I mean, it's distributed stuff, right? So you get a propagated change, and I got the response from all the nodes that they acknowledge it, they accepted that they acknowledge it, and then what I do is basically there's an atomic operation. I just swap this ID to a new one. So with this swap being basically the ID is unsigned integer 128 bytes. Bits, sorry. 128 bits, which is the basically an atomic size of a unsigned, obviously, which is the size for a standard CPU accumulator and for a standard CPU register. So the change, I mean, yeah, I also got to propagate the change, but it's much less overhead, and there are really only a few things which could go wrong. And this pointer, for example, I'm calling it pointer. This ID I have to touch. I don't have to touch. Yeah, so I'm just updating this key value storage here. The inode key value storage, and those two, I'm either deleting something or I'm creating something. So this is basically these elements here are basically mutable. And at the end, like once in a while, that's the problem. That's the only problem. I have to build out the whole tree, and I believe it's called tree shaking or like something similar. I'm just deleting the entry because it's not. I see that it's not linked from anywhere. It's not referenced anywhere. So it's the like why do I need it in the first place, and I'm just deleting it once in a while. But since it's just an entry, it does not contain any actual data here. It's just the entry, where to find. And here actually there's some data where to actually find the file bytes, the file chunks or whatever. And these basically point into the same direction. So yeah, and I'm just and this we got here, and this we can just get rid of. Which would be also, first of all, more or less atomic, and like getting rid of stuff. I mean, we're not using it. Why do I have to even bother with it? So there's a lot of smart things going on actually. And I want to again I didn't thought much of file systems and storage systems. Well, we implemented some basic stuff at the university, but yeah, now I'm more kind of into it, and I see like how many interesting, like really interesting solutions there are, and yeah, that's really funny. That's actually really cool to implement something yourself, something like that. And now I know how distributed file systems work. And again, even with the university, I wouldn't have known it. So I hope this one, I hope this explains. I hope this really explains the thing. Yeah, so yeah, the file lookups, let's go, hope this goes well. Yeah, thank you. So again, why did I even start the project? Because there's this, again, there's self storage, as you maybe know. There's the self storage, which is but it's not a storage itself. It's a large orchestrator daemon. Wait, I have to switch back the music because because of the copyright stuff. Hopefully I'm not getting any ban or any problem with that. Yeah, so the SAF has a problem that first of all it requires like an enormous overhead. It has enormous overhead, especially on small files. Um, yeah, and it's just messed up. It's a huge damn stack. So Ceph is like a very large stack, requiring I think uh, at least 3 servers. Recommended at least 5 servers nodes. It cannot, for example, work with RAIDs, neither with software RAIDs, nor with real physical like RAIDs. It cannot. I mean, you could get a data loss there if you're using even a hardware RAID, which is like why? And I mean, there's a tiny Ceph called stuff called technology by Ubuntu or Canonical or whoever. And I was like thinking, and like me and a couple of other guys who are like interested in such thing. We're like thinking, well, we have like different tasks. We have different things to do. We are gonna be starting with one server, and we're gonna be scaling it up, and we have to get it fast, get it rapid, ASAP to make it run, and it should be one binary, which is at the end that's gonna be it's gonna be just like one binary with synchronized configs and whatever, and yeah. So that's gonna be that's the point. And again, I'm always up to well learning something new. So where were we? There's the file, and we have to create new. So what data are we actually getting from the file? Create um create a new file. Um, create a UI node. UI node. Well, we gotta create a new file and the new. Oh, well, I have to first of all create a new metadata and a new inode for the file. So, what we can do is again, what data are we have? Are we having provided here? File. What does it have? Logs and links permission kind yeah parent. Okay, that's gonna be important. We have the parent, we have the name, we have the mode. What is a mode actually? Mode, is it like executable or something? As mode. Um, yeah, I'm paying for the whole Copilot. I'm gonna use the whole Copilot. What is a mode? Integer. That's interesting actually. Yeah, read write. Using involving file systems, mode, integer, file types. That is a regular file directory, symbol file. Yeah, sorry. File type and mode integer is a combination. Oh shit. with the directory permissions. So I have to determine based on the mode. It's not create a file. File symboling and right. No, the create fuse file system specifically for creating regular files. Oh, thank God. So we don't have to like determine it here and there. So it's create. Okay, good. Um, Directory with the certain permissions. For now, I think for now we can just ignore it. I think we can like. I mean, we're also gonna like come sooner or later for it, but we're gonna ignore it for now. Also, a nice thing would be later make make the distributed storage also what was it called again? Amazon S3 compatible. So the existing code base for the Amazon S3 buckets. If you, for example, that's one of the cases in my at my well, I got from my colleagues. They do not trust Mr. Bezos. They just don't want to. Again, in Europe, all the data protection law is just a horror. But I mean, there is a reason why. Yeah, that not with other reason. I kind of support it to some degree. But you really have to store the data within the EU, have all the access and etc. And specifically like sensitive customer data and using Amazon buckets for it is not the best option whatsoever. So that's also a point. So we have basically a name or a string. We have basically a noise string and the parent. So we don't have to parent 28. The parent, the name is it? No, it's not the pointer. It's gonna be a string. A name, maybe KVM. Okay, work with the no. This one we are gonna be resulting a tuple of inode and file. Use what kind use create storage just generate unique ID. File ID, the inode ID. These are, I mean, yeah, let's just leave it as this. File content hash size 0. Um, um, Networking file system. Um, yeah, we'll leave it as 0 now. 0 inode. The inode ID we have. The target we have. And now we have to point example block size. That's actually, yeah, that's actually pretty much what I wanted to use. But now we have to create it some, I mean, like, it's gotta be created, right? But that's gonna have to, it's gonna have to appear somewhere. In our case, it's gonna have to appear here, and not just only here. We are creating a file, so we just appeared this one here, and so we have just well created this one here. So that's one, and we have just created this one here. That's two. So now we have to actually create a duplicate here, duplicate the entry, duplicate the entry, move it to here. And the directory we actually got. Store. It's this, so we're first storing it here in the directory. Function get directory reply. Then we add the entry. We're not allowed to push anything. Function. Is it copyable? Derive. Copy the directory entries. The directory metadata. Oh, so we could, yeah, we can add it actually as a trait. Fuse manager. Trait. Copy meta. Copy meta. New copyable fs. Copy entry with new ID. Yeah. So that's self, and copyable fs. So a file should implement the copyable fs. Although we'll do it later. Directory is more important. Is for more of interest now. Implement fuse fast utils. Huh? Fuse manager. Great. Document. Use super copyable FS. Implement copyable FS. Straight. Oh yeah, so we can tell it is straight, but UID, we generate a new ID indeed. Super.utils, we move it up here. Gonna use utils generate random, generate unique ID, generate unique ID entries. Entries we clone. Right. Yeah, and now we have, oh, ID we can get like instantly. So creating a file. It's a new file and a new inode. We just created them. We created them, we initialized them. Also, why can we store it? They should be like inaccessible. So we all right. So we get to the directory. We get up function add entry. First copy the directory. Although we could even copy entry with a new ID. To create ID keeping the immutable properties. New directory. No, that's a mess. That's not gonna work like this. It's a bullshit. Directory is copyable offense. Okay. Self. Directory the entry the push is the new directory entry. No, we don't actually update this self. We do not update this self. Or back to the KDS. And actually, oh yeah, mutable self. Yes, okay. Result we actually directory, and we have to return. Yeah, 1.5 hours. It's 3 a.m. Yeah. Okay. Directory. Oh, this is running. Oops, sorry. It doesn't have to. It should. Device resource busy. Okay, so it just black for a brief moment. Okay, so we return the new directory which is already stored. Add entry. And then what do we do actually? At this moment we file. inode, inode, file ID, inode ID, parent. Inode equals inode.get.id, and nope. Parent is not a directory, which is obviously an error. Directory get by ID. Parent inode.target. Target target EVS.1. Yeah, that's just to be sure. Yeah, just we done it. We don't actually need to do this, but me makes an extra EVS call. Optimize later. Yeah. And so we don't care about this. Parent directory. So now equals to new directory metadata to avoid mutability issues. Why is it parent directory? Why is it the new parent directory, which is actually a directory dot copy with new ID. Also, it's the parent directory dot copy with new ID dot push. We are pushing here a we are pushing here. What are we pushing here? Dot add entry. Dot entry name inode ID. Um, I know, but I didn't do KVS. Um, so we have a new parent directory here. We got a inode. Um, and for the inode, we can cheat a bit. Then, swap target. New target, and the handle for the connection. KVS. So we actually gotta do the but the update. So we're swapping out the target, right? And swap target. Paradigm node. Swap the target, and we are good to go. So we're swapping out the target here, and yeah, let's run. And yeah, I was expecting to get a hell out of errors. Well, first things first. Move the use. Yeah, that's not gonna work for now, obviously. That's for now. Yeah, so we're just gonna be suppressing the compiler for now. Shit, it started like creating like allow unused like everywhere. Shit, this is just like driving me nuts. I really like hate it. Just gonna like create it in all new files. Yeah. Address, okay. Something we got. Yeah, I mean, like, I still don't kind of particularly like Rust, but again, I'm like kind of learning it, and I started to get this kind of, well, I mean, I slowly understand the semantics here, but expected identifier, Jan, use. Will that one help? This one I really don't have any idea why. Jen, what? Um, yeah, sorry, expected. Yeah. Okay, now we have something. Storage directory. Use storage directory. Yeah, we're slowly getting rhythm. Oh yeah, sure. Red engine. Where is it exactly? I mean, like it's. That's a warning, but that's kind of. Also, I can't. This freaking generator. I can't imagine if it's it of being a being the UI node. Not. Oh, mm, mm, wait, wait a second. Do we actually to have to create a new item? Oh yeah, we have to create new n instances, which is a tuple of I know the file. I know and a file. A file dot file create new name the variable string. Oh, I mean, I kind of like the syntax here. Parent, okay. And you will out get KVS and UI node. Oh yeah, obviously. Uses is an error. Get UI node in file. Actually, attributes. Attributes, UI node. Oh, can I do this? UI node. I node. Can I attribute? Yeah. It should work fine. Attribute. Yeah, that should work. More errors. Okay, but these are like important ones. Like not necessarily. First and second. So both should be solved now. Oh shit! No, we're getting like really fucked up. Yeah. Why exactly are you? Oh, it's just its parameters declaration create up 7. So expected sound parameters. Provide E32. That should be reply read umask. Yeah, the umask, whatever it is. Yeah, whatever. The umask. Yeah, I think we have associated file. Did you create new? Arguments to this function are incorrect. Parent name KVS, right? Create new. Oh, parent name KVS, key value storage. Found for tuple in current scope. Is error. New instances. What is it exactly? New instances. Oh yeah. Sure. It's not mutable for now. Oh yeah, and the parent is let's see, 28. Shit can borrow is mutable. Considering where exactly mutable. New iron node. Mutable. Mutable as well. Okay. Hiding a lifetimes that the light as elsewhere is confusing. Okay, so I mean, like, let's read the warnings for a second. Module if essential should have a snake case name. Fuck you. Should have a snake case name. Fuck you as well. Constraint never used. Go fuck yourselves. Okay, that should have. Fuck you. Get rid of this connection. Is lighted here. The same lifetime is referred in the inconsistent ways, making signature confusing on by default for type path. Explain. The problem, return types is mutex, Redis connection. The compiler is pointing out that the lifetime mutex card is a little light that no explicitly written, which can make the code harder to understand. Specifically, the lifetime of the mutex card is tied to a lifetime of self, but this relationship is not explicitly stated. Why it's confusing. The compiler warning just hiding the lifetime, but also writing it can make the code harder to read and maintain, especially for others who might work on the code later. The warning suggests. So is it like music guard? You're explicitly stating that the left and music guards try to borrow of self that makes the code more readable and avoids the warning. I mean, like, yeah, sure, why not? I mean, for me, it makes code like even less readable. But oh, and it makes an error or something. Oh, so sorry, I just forgot something. Yeah, that should work. That should work fine. But transport endpoint is not connected. Um, device or resources busy. Fuse fast. Storage. Directory. Tests the fast exists. Why exactly? Test the fast. Transport endpoint is not connected. What the fuck? Oh. Now we dismount it. Harbor run. And now here. Test.txt. Input output error. Huh. Not happening. Why? Why isn't it happening? Oh. Use of this. Create a node. This debug we just delete. Oh, still I know the rest. Look up. There were like a couple of functions collapsed. Yeah, here we have them. Here we got them. Oops. Yeah. I'm not it. Loaded inode with inode ID1. Um, Interesting. Verify the mount point. Lookup called with the parent. Debug logs the lookup method to confirm it's being called when you run. Touch trace. Touch system calls. Okay. Lookup. The apt install as trace. Just unmount. Then we mount it. Trace. Um, yeah, best viewers on streambo.com. Yeah, I'm getting spammed on Twitch again. Wait, I'm just gonna ban him. Boom, it's banned. The dude's banned. Who wrote some advertisement on Twitch. So yeah, as you can see, I mean, it doesn't even call the create syscall. I mean, like syscall. Not the syscall. I mean, like. So that's what I see now. I believe I can show it. There's nothing. Well, nothing usually here. So we create, load the inodes. I mean, yeah, the inode lookup, it works, and it happens like very damn often. So execute and map some memory. Yeah, well, that's a cool stuff actually. I didn't know there's like this command which like really like gives me all the syscalls. I mean, or I can even like see the C code basically. So it's TID address, limit, break or bark, whatever. It's called opennet. Cast, exited with a 1. This is follow directory message core utils dot imo. Um, it's clear how the lookup method is being called for test.txt, but the create method is not being invoked. It indicates the lookup method is not returning the correct code for enoent when the file does not exist. Instead, it seems to be returning a success response, which prevents the kernel from calling create. Oh, so wait a second. What's the problem? Uh, it files directory. Yeah, I'm gonna accept it, but what's the point? I mean, I was thinking like, here directory entry, find entry. I mean, the entry is none. Okay, run. Oh, so it's that legacy? Not this shit. All right. So entry, it requires the entry inode. So the directory should probably the function find entry, huh? Find entry none. No, it should be a result either an inode or an error. Kind, we got import use io use std dot error. Okay. Um, none is okay. Entry error. Also find entry mutable KVS new. What the shit? That's a mess. KVS dynamic error. Box new. New. Yeah, that should work. Yeah, this as well. This we fixed this well. Hello? Anybody here? Oh shit, this error again. Somehow does not make any sense. But yeah. Dynamic error. Can we just like reply with an error? Can we just reply with it and not with a box? Use move to valid target. Result. Dynamic. Shit. I mean, like it's getting even more and more. Each and every time, it's getting like more errors and more errors. That's the problem I got with Rust. I mean, it doesn't help. I mean, it or just a bit. Can be known at compilation time, dude. Like. Option. That's it. Some inode or none. this we fix, right? Oh yeah, and obviously here dot okay. We assume it's okay. Um, also here is error. If entry, with a similar name iterator. Um, is none. Then we return the not found. Nine or whatever it's called. Okay, use of moved lookup. Um, hmm. That's more of a hard one because um you really gotta know the whole bullshit with the um fighting borrow checker. This god damn it. I mean like that's why for example somehow still love C because I mean you don't have to fight it and as my computer science professor once told me, well, who is like a huge fan of C, he told me like, well, if you know what you're doing and you're I mean like if you know what you're doing, you can get it right, and if you cover everything with tests, you'll get it right. It's not gonna be a problem. Um, yeah. So takes ownership. Use of moved value target. Target of unwrap. Uh, why? Target dot unwrap dot zero. Huh? Yeah, that's move to this due to this method call. Okay, so first of all, is there is an error. Um, we're not gonna do any. Okay. Um, parent. Then yeah, you search a specific file system implement not multificial file system typically rely on structured data. Receive the directory inode, access the directory mappings, check if the requested name exists in the directory's entries, then this corresponding inode. Oh, oh. Um, wait, huh? The transport endpoint isn't correct. Yeah. Oops. Okay. Red at panicked at inode or res. value was no. Response type not string compatible. Failed to get directory by ID. Failed to get the directory by ID. Alright, directory by ID. Get by ID. Fetching directory by ID. Um, let's unmount it. Run it again. With IDs. Storing inode with key. Well, why do we store it? Why in the hell are we actually storing it? It didn't make like any sense. Any at all. So let's move to the other display. Inode. Yeah, there's some certain random integer. Storing inode with key. Fetching. Huh? Fetch directory with the one umask. With where are you? Like create parent one name is equals text test.txt mode and umask store. Storing the inode. Okay, so it's somewhere in the file, right? There's this create new. Um, hmm. Hmm. Created inode with the key. Okay, loaded inode with inode 1. New parent directory. New parent directory.store. So we're storing it. Did I just forget to store it? I sure hope, fucking hope I did. So we did get an error. Fuck me. There's so many of them. What the fuck? There's so many directories and files here. What the fuck? Mm-hmm. Again, SFS. The directory for some reason. Oh, so it's not a reference anymore. Alright, so that kind of directory. Entries. Parent inode. Target is 1. So it's not being swapped correctly. Yeah, that's not going. Oops. Oops, the music just ended. Video post. Yeah. So we are here. This inode, the swap target. The new inode. Oh, so we're not swapping it in the inode, obviously. I mean in the new inode, we are parent inode, and in the parent inode, we swap the target. Parent inode, and here we store it. So that was the problem. Yeah. Oh no, that start making sense. We have to swap the parent inode, no, not the child inode. I mean, like, it doesn't make any sense to swap something, right? In the child inode. Wait, let me mark it. The updated directory. The old yeah, so that's gonna so that's what can actually happen. Um, that's what's gonna happen. Unmount it. Right. Oops. Cannot borrow is mutable. Parent. Where's parent? Oh yeah, it's not mutable. First, like mutable. Mutable when it doesn't have to be. Right. As we are inside. Touch. If I was touched. Yeah. Refresh now. So we have created a new. We have two new directories and two new files. So the inode is pointing to a new directory. 2.1. What the fuck? Directory 2.1. Whatever. 8.2. 8. The inode ID is 8.2 something something something. 8.2 is target 204. Kind of file. I mean, yeah, that seems to work, but first things first. Target 1. Target 1. I just updated it. We are touching the file again. TXT. Yeah, it doesn't have anything. Test.txt. Test.txt. Oh, so it even creates the files. Cool. So we are creating files now. Yeah, but I completely forgot about the one test we have to run before we are finished for tomorrow. Or for today, and we'll continue tomorrow, hopefully, or not, depending on my schedule. Use amount, run. Nothing new. Set like this here, nothing new. Okay, batch test 1 to 3. Well, that's a mess, because it's nearly everything is correct. But not the but not these two. So one of them is wrong. Doesn't need to be here. So we have an inode. Target 196 is a directory. 196 is a directory. That's strange. Because it doesn't make any sense. Otherwise, it wouldn't have worked. But it works, and that's the funny part. I don't know what. I don't know why. Yeah, some blocks, some hash, whatever. We don't care about it though. 2872. 2872 is one. Is connected to a 9 node. 18788 something something 1788, which is 1788, and it's the ID 1835196. Huh. Yeah, that's odd. That's strange. That's odd. That doesn't make any sense. Fetching directory. Car clean. Let's first clean it all. Directory. Get links. Copy. Copying. Intro directory with the ID, new ID, and links. Links number. Yeah. Oh, so it's actually cargo run. Let's just rerun it and see what we're gonna be getting. Oh yeah, sorry, I just didn't fully unmount it. Yep, now, first of all, here, then we have to delete the old entries here. Again, sorry for using Redis, but target is one, which is a directory. Sorry for using Redis, but again, it's the key value storage, which again, it's like hot pluggable with an interface for exactly for that kind of reasons, for debug. So it's empty now. We just starting this thing over here. Testfs. Create the function, for some reason setting times of test function not implement. Times. Yeah, I'll have to like see what's wrong with it. Let's refresh for auto refresh now. So again, it's created two directories for certain reason, whatever reason. I don't know which exactly reason. It did create two directories. Copying directory with ID. Wow. Now we unmounted it. Um, get by ID. We get a parent directory, which in this case is one. Copying directory. Links to copying directory with ID to you. Why are we copying it? Where exactly are we copying it? Yeah, I really have no idea why. So why does it copy it? And the largest question is, why does it work still, though it really shouldn't? Like this thing really should not work. So again, we follow it with an I know that 1, 903, and whatever, 903, which is a directory which has no entries, as you can see, no whatsoever, none, 0. Oh, it's 3:30 a.m. Right, it's very late. That has no entries. Yeah, let's freaking update it. It has no entries. 768. And also that's the ID. And the other ID, which well, it stores everything and it works, and it works. So the ID 309, which isn't referenced like anywhere. Or is it? 309. It's a file. We don't care about it now because it's the file and it works. 108 something. 108 something. Yeah, we know that it works. The entries, there are no entries here. Although the inode 1 shows to this one, not to the other one. And that like is driving me nuts. Because why? And if so, it shouldn't work. I mean, yeah, I might know why. I might have an idea why. I might have an idea because we're caching it. It's cached. It's not like soft return. It's like, I mean, it's like not recached. I mean, it's not refetched, but it's cached at the beginning, and that is the problem. So wait, copy it twice. The first copy happens when creating a new file, and the create new method. The second, this creates a directory instance occurs when the add entry. Oh, so we don't actually have to copy it. Yeah, sure. Oh yeah, sure. Um, directory, find entry at entry. Directory copy. We're copying it 2 times. This should work. Test fs. Test.txt. Functions in order. We don't care about it. Yeah, see, here's the problem. It doesn't properly fetch anymore. But here everything's in order now here. Again. Nine, whatever, and everything works just fine here. So that's gonna be the end of today's stream, guys. Thank